So I'm Timo Rasanen. I work as senior cloud engineer at Nokia, and I'm based in Finland, and I have a networking background. My presentation today is about the data center automation and how we use NetBox as a sort of tool in our infrastructure. And in this presentation, I'll tell you briefly what our team does and a bit of our infrastructure. Then I'll tell you how we basically populate the information into NetBox with our rack creation process, as that's the first step on our automation pipeline. So we have many automation use cases which involve NetBox, but I've selected this one as an example because that's the initial step on our automation efforts. And I hope that maybe someday I'll have another presentation here that I can show you other automation use cases that we have. And in the end, I'll have a demo of this rack creation process. So few words about the NESC. So our team is Nokia Engineering and Services Cloud. So that's Nokia's internal public cloud offering. So we provide OpenStack, Kubernetes, storage, bare metal databases as a service. And if I would need to describe our team with one sentence, so we provide cost-efficient cloud computing for Nokia's internal use. So NESC was initiated back in 2010 with a few servers, and it has been steadily growing year by year. So we have 7 data centers, roughly 400 racks, 12,000 devices, 720K cores, 50 petabytes of storage, and roughly 5,000 accounts. And we have been using NetBox in production since 2017, and we started it off with the network devices, but the rest of the infra was taken into scope rather soon after. And we use pretty much all the features NetBox provides. And we have rather many integrations with NetBox, like we generate configurations, we integrate with the DNS, DHCP, dynamic inventories, we enrich log events with the NetBox data, and so on. And then about how we populate the data into NetBox. So our rack creation process. So as our infrastructure is rather large, so automation is a must, and also defining the source of truths is also a must. So this means that we need to document everything first to NetBox before we deploy anything to production. And in case, the most common use case is adding new resources, start by adding a new rack to NetBox. And the initial steps for creating a new rack is regardless of the rack role, so whether it will be on the OpenStack or Kubernetes, we need to add the rack itself, we need to add the devices into rack, document the power and interface cabling, allocate IP addresses and prefixes. And then depending on the use case of the rack, we add like tags, AS numbers, assigning config context, and so on for that specific deployment type. And if we think about a typical rack, we have servers, of course, we have PDUs, interface and power connections, IP addresses and prefixes, and so on. And if we would do this kind of operation via the GUI, it would be more than 400 operations. So it would be time-consuming, boring, and very error-prone. So it's basically impossible to create this manually via the GUI. And the only option is basically to create this documentation with the code. And it's very important to make it right, as basically the rest of the automation relies on this information. So we have a lot of history behind us. So we have a multi-vendor environment. We have multiple device types, multiple different rack layouts, different cabling, and so on. So and we have different rack types, like a compute, storage, GPU racks. And we started tackling this issue by creating templates for these data models, which are then processed with the Python script, and the data is then based on that created into NetBox. So basically, one template creates the devices that are in the rack and how they are positioned in the rack. The second template basically defines how we want the devices to be cabled. And the third one describes how the IP addresses and prefixes should be allocated. And there are other templates as well, but this is just the common to all the racks. So we created these first scripts over the REST API, but we started using custom scripts as this feature became available. And for those who are not familiar with the custom scripts, it's a feature that allows you to run your own code within the NetBox app. And we selected custom scripts over the REST API because of the nice integration with the NetBox GUI, the speed and support for transactions. So if we would run the similar feature over the REST API, you would need to take certain exceptions into account. For example, that if the, let's say, connection fails in the middle of rack creation, you might end up with a half-baked rack. And here's the example of the templates that we use for creating the racks. So it's a YAML file. It describes the rack dimensions, rack role, the devices in the rack, and what kind of cabling templates we should use. And we also define here the PDUs as non-racked devices. And then we have the cabling templates. So this is an CSV file, which basically each line represents one cable. So there's a definition of the U position of the device, then the interfaces, and the label that we want to add to the cable, and of course the cable type. And similar CSV file for the power cables. So it defines the PDU, the power outlets, and the device position, and the PSU. And we have another script for allocating the IP addresses, and there are certain parameters that the user needs to enter to get the IP address allocation done correctly. And the template for the allocating the IP addresses is a YAML file. And there's basically a logic that how to allocate first the prefix. So for example, in this case, it's allocating a /26 prefix from a parent prefix that has a role OOB and the tenant is shared. And then we allocate the IP addresses from that prefix, and allocation is done based on the device position in the rack. And this is a slightly simplified example of how we allocate the IP addresses, but the logic is the same as we have in production. And then I'll have a short demo of this setup. We have this script for creating the rack. So we first select the templates which should be used. We specify the site, the location where this rack is located, and we give the name for the rack. We also document the asset tags and the purchase order. So this has to be some unique numbers. And then we also document the power and how the rack is connected to the power panels. So we need to select those. And in this case, I'll just use the try run feature. So just to test it out that everything works fine. So it doesn't push any changes to the or write any changes to the database. And this should take roughly 30 seconds to run, and then we can actually create that rack. And this is this try run feature is a rather nice feature to test it out, so that there, for example, isn't any issues, for example, running out of IP addresses or stuff like that. And this one takes when you on this my dev instance or demo instance, it will take like roughly 1 minute or 1.5 minutes. So if you have any questions right now, just let me know while we wait to complete.
I have a general question. So how long were you sort of doing this process manually before you decided that a script was a better approach? Because I love seeing script use.
We basically did it from the beginning.
Oh, smart.
Okay, so now it was created, and we should have like N12. And we have the rack here. It was created, and we have the PDUs. All the cabling is done there as well. and the connections cables have the correct labels and so on. And then we can just run the other script for the IP address allocation. 12, and in this case, there's only one template for this one, and we can just run this one. And everything looks okay.
Very nice.
And if we then select the rack and let's pick up one device from there, and we get to the prefix, and I just want to show that these are the IP addresses that were basically allocated for the rack.
Cool. Awesome.
That's all from my side.
Timo, I really appreciate you coming on and sharing this with us. It's really cool to see how Nokia is doing this inside of your data center setups. It's again, I like script utilization. Sometimes it's hard to figure out what's the right fit and feel for a script, but it seems like you all have been able to do that really well.